Before I dive into the notes too far, I want to show you this and talk to you about this. Here is one triangle. I have 1, 2, and I have 3. And I have this triangle, which is 2, 4, and 6. I'm going to compare my two sets of sides. 1 matches up to 2, right? I get 1/2. 2 matches up to 4. How does 2 4 simplify? 1/2. And I have 3, 6 matches up, which simplifies to 1/2. What's my scale factor? My scale factor is 1/2. Okay? How about this? What is the perimeter of this one? What is perimeter? The distance around. So what's the distance around this triangle? 6 units. 3 plus 2 is 5, plus 1 more gives me 6. What is the perimeter of this one? 12. So here's my question. What's the ratio of the perimeters? 6 to 12, which is the perimeter. Ratio of the perimeters is 1/2, which is the same thing as our scale factor, right? The ratio of the perimeters is the same thing as our scale factor. Got it? Here's how we fill in our notes now. What does the perimeters of similar polygons theorem say? It says if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding lengths. If I find the perimeter by adding up all the sides, each of those are going to be equal to the ratio of the sides. The perimeter is equal to the ratio of the sides. So we have KL to PQ is equal to LM to QR, which is equal to MN to RS, which is equal to NK to SP. So in the diagram, ABCDE is similar to FGHJK. What does similar mean? Corresponding angles are congruent, corresponding sides are proportional. This class is doing decent, but let's go here. Let's do this. On your paper, somewhere in the margin, turn it sideways somewhere so that you have room to write this. We need to get this down. Similar. This is just because you need to know it. Yeah. This was actually, sure. This was actually the definition on the front of your page, but we're still missing it. Yeah, so put it on the back. Similar means corresponding angles are congruent. Corresponding angles are congruent. Corresponding sides are proportional. Corresponding angles are congruent, corresponding sides are proportional. That's what similar is. Similar figures. We're going to get there. We're going to compare two sides. How are they proportional if they all simplify to be the same thing? So check this out. Part A says find the scale factor of FGHJK to ABCDE. It's important that you pay attention to that because it's telling you which figure we need to start with. So I start at figure F and I go to figure A. To find my scale factor, I need to figure out what two sides match up to find the scale factor. I only have a 10 here, right? A, B, and F, G. This side matches up to this one. So when I find my scale factor, it says start at this one and go to the other one. I start here and I go here. So on your paper, you should have an arrow drawn in there because we need to know we start here and go towards that one. Again, don't be too confident that you can't draw your arrows. I always draw my arrows. Okay? We started that one, go towards this one. So it's 15, 2, 10. How's it simplify? Bless you. Bless you. 3 over 2. That is called our scale factor. okay? And I'm going to use that to find the value of x. So instead of saying 15 to 10, when I solve for x, I know that this is the same thing as saying, well, like 3 to 2. It's not the side lengths, it's just the ratio of the sides. It's your scale factor. So to find the value of x, what does x match up to? 18. So if I said 3 to 2, that's the same thing as saying I can use that 3 to 2 to solve for x, and we say 18 to x. 3 to 2 equals 18 to x over x. Cross multiply it. Solve it. 2 times 18 is 36. X equals 12, so I can put 12 on my picture right here just to see. Just pretty much check your work. So if we have 18 to 12, just to check your work, how does 18 to 12 simplify? Divide the top, divide the bottom, both by 6. 3 to 2, it's still my scale factor when you kind of like plug it back in. That's one way to look at it. See? Find the perimeter of A, B, C, D, E. Here's A, B, C, D, E. That means I have to find these other 3 sides, right? I don't want to do that. That's a lot of work. So here's where this theorem comes in that I tried to show you at the beginning of the hour. If I find the perimeter of this one, I can use that information to find the perimeter of that one because I know my scale factor. What is the perimeter of this one? What's the perimeter of this one? How do I find the perimeter of that one? What is perimeter? All the distance around the outside edge. Yep. So the perimeter of this is 18 plus 15 plus 15 plus 9 plus 12. When we add those numbers all together, 69, you get 69. So the perimeter of this is 69 units. So check out how this works. The scale factor is 3 to 2, and I know this perimeter is 69, and I don't know what that one is, so I can compare these. I've got these arrows telling me how to set it up. We have 3 to 2, and I'm going to compare 69 to x. We can call it x. My scale factor was 3 to 2. And to find the perimeter of this one, if I know the perimeter of that one, I can use that same scale factor. 69 to x. I'm going to compare this perimeter to that one, just using the scale factor to set it up. We can cross multiply. 3 times x is 3x. 2 times 69 is 138. And divide. Thank you. So I get 46 for the perimeter of this one. If the perimeter of this was 69, could that one be 46? So what is this? Just clean it up. The perimeter of A, B, C, D, E equals 46 units, because they didn't tell us what the units are. So how about here? In the diagram, triangle BCD is similar to triangle RST. Find the value of x. It doesn't tell me which one I have to start with. It doesn't tell me find the scale factor. I can just start right away, and I'm like, well, what does x compare to? I need to write a proportion. X compares to 13, right? Doesn't matter which one you start at and go towards as long as you draw your arrows in and you're consistent. I can say x to 13, and what else can I compare? B, C, and RS match up, right? I could say x to 13 and 24 to 12. Here's my only hesitation. 24 and 12 are big numbers to multiply with. What else matches up? 5 and 10. So I start at this one and I go towards this one. And the only reason I'm picking that is just because I can't do mental math when it gets too big. So what do I have? X over 13 equals 10 over 5. Or if you said 13 over x equals 5 over 10, you're going to get the same thing. Yep. X equals 26. I come to my picture and I plug it in and I see. What do we have? A lot of you probably did this in your head. Yeah. Yeah. So some of you are like, hey, 10 divided by 2 is 5. 24 divided by 2 is 12. So 26 divided by 2 is going to give me 13. As long as you show me your work, yeah, that's going to be a great way to do it. What's the scale factor of element P to F, G, H, J? It tells you you have to start at the figure on the left or the figure on the right. I have to start at this one. It's this one to this one. What sides can I compare to find my scale factor? Which two are corresponding? JH and PN, those match up. So can I come here and find my scale factor here? It's element P, so I start at this one and come towards this one. So I have 12 to 15. What goes into both of those? 3. 12 divided by 3 is 12. 15 divided by 3 is? What's my scale factor? 4 over 5. It's like 4 to 5 is my ratio of those sides. What if Corey said, hey, Mr. Roop, how about LP to FJ? I want to compare 16 to 20. Could we do that? Why not? If they're similar, they should all come out to the same scale factor to be the same proportion. 16 divided by 4 is 4. 20 divided by 4 is, look at that. We still get the same scale factor, as long as your corresponding sides are the ones that you're comparing. Find the value of x. We have our scale factor. It's 4 to 5 equals, here's where we come back to Kaylee. How do we solve for x? X compares to 40, she told us. It was 4 to 5 compares to x to 40. Solve it. X is 32.